Quinsland, probably. Yeah, I'm like the world's worst salesman. I don't. My GitHub stuff is usually just task related, project related. I almost never do something in general purpose, but. Okay. I should be good, but it's one of those things where, when it craps out in the middle of a presentation, it's really embarrassing. No worries. I'll try not to step on this. Wow. Wow. Cool.
Okay, so we're going to start our second talk for the day. I'm pleased to introduce Mark Quinsland from Neo4j. So Mark is a field engineer with Neo4j and has what he thinks is the best job in the world because he gets to travel all over the world, helping really cool companies solve really interesting problems using ever-changing state-of-the-art tools. He'll be presenting a talk titled From Panama Papers to Russian Trolls, How Graph Databases Are Revealing Hidden Relationships and Exposing Corruption. Please join me in welcoming Mark.
Cool. Thanks. Yeah, thanks. This is great. I had this fear that no one would show up, so this is obviously a popular presentation. So first off, how many of you have heard of the Panama Papers or the Paradise Papers, Russian Twitter trolls? So we were heavily involved. Our company was involved with that. So I kind of want to show some of the things that we did. This is from a presentation we did at Stanford just a couple of months ago. So I'll put the link out there for anybody who wants to see the full length version of it. This is kind of a summary version of it. So basically, graphs are really good at helping you do things like follow the money. So I was alive during this particular time period, and I see a lot of similarities to what's going on now. So it's very topical, but basically, graphs are really good at helping you connect the dots, and connecting the dots often means following the money. So about me, like you said, I'm a field engineer for Neo4j. I get to go do a lot of pre-sales work where I'm helping companies set up graphs for the first time, trying to explore the things. This is the love of my life, Abigail. Everybody gets to see a picture of Abigail no matter where I go. So anyway, I miss her terribly. It's my LinkedIn information. I think that's available from the slide deck. These slides will be available later for anybody who's interested in them. A little bit about Neo, briefly. We are the world's leading graph database company. If you're doing graphs and you haven't heard of Neo, then you're probably not doing it right. We are used by most of the world's financial institutions, a lot of retailers, government agencies, investigative journalists, lots of anybody who has a vested interest in figuring out who you are in context to other things, the things that you do, the things that you buy, the people that you know, the places you go, the things that they think you should buy, that kind of stuff. That's where graphs fit in. So you guys know how to read, so I'm not going to read to you, but basically we've been doing this a long time. We've got a lot of people who have just come into the graph data space lately, but we welcome them and we're glad that they're in there, but really we work with some of the world's leading companies. All right, briefly, what is the impact of connected data? So we're not just a simple relational database structure. Relational databases are really awful at how they do joins and that type of thing, but connected data is really, really important. So this is from Gartner. You should know who Gartner is for recommendations, but basically the power of connected data is really pretty strong. Again, the takeaway from this presentation, if nothing else, we are really good at being able to store and query data relationships, connected data. So the old adage that NoSQL is, you don't do joins. We're not really a NoSQL database because we love joins. We are the primary platform when you have highly connected data, stuff that relational databases can't do, that you wouldn't even have to do with Mongo or Cassandra or something like that. So we are there to traverse any levels of depth, like 6 of separation, 7, 12, 15, things that would just kill a relational database. That's what we thrive on. Also, when you're working with graph databases, they're so flexible. The idea is that you have lots of different kinds of data that you can bring in. So trying to do a join against a bunch of different Oracle tables would be pretty difficult. But we do this stuff all day long. So you do this crawl, walk, run process where you start off with one kind of data and you add a new data source. So when somebody comes to you and says, hey, can you add this to it? You're like, sure, not a problem. And it's usually not a problem, or that might take a lot of additional work in a relational database environment. So you're joining dissimilar data sources because the structures are so simple. They're so easy to connect that you don't get bogged down in complex schema operations, which makes it really useful when you're trying to work in a connected enterprise where you've got lots of different sources. You've got CRM data, you've got sales stuff, you've got marketing, all kinds of different data sources that come in. And this is where graphs typically shine. So these kinds of things are used in not only in marketing recommendations, but the converse of that is like finding fraud, which is the purpose of today's talk. So we're going to talk a little bit about money laundering. I have to do kind of a brief thing. Money laundering doesn't mean this. It's basically using some kind of structure to hide money. So this is the United Nations drawing for money laundering, and it typically involves a few things, like you have a source of money. Source of money can be organized crime, drug cartels, you name it, embezzled money. There's all kinds of people that are embezzling money, stealing money from a variety of sources, or just trying to hide money in general. It typically goes through a placement process into a bank. If you need a corrupt bank, Deutsche Bank would be a good place to start. They're involved in a lot of money laundering. But most banks have anti-money laundering statutes that they adhere to, but there's a lot of corrupt banks out there as well. Casinos are also a great way to do it. So if you know somebody who owns a casino, they're a great way of moving money around. But this part in the middle here, this circle, and I kind of lost my laser pointer, this guy here, this is really where the graphs come in at helping you find things, because you're typically using companies that create a structure of obfuscating where the data flows. So this is where graphs really come in handy for being able to find things. And then eventually you're going to pull the money out, and you're going to take it out, and now you have clean money. Clean money is frequently used in like a high-end real estate transaction, buying luxury goods, diamonds, anything that's saleable. You might take a $500,000 or $1 million in bogus money, you run it through your friendly casino or bank, you pull it out and you invest it into a condo. Say you pay $800,000 for a condo that's really only worth $300,000. The guy who handles the transaction pockets the $500,000, but you've got $300,000 that you can now do whatever you want with. So that's really a common thing. To do that, people use complex structures like this is a cyclical structure that's really, really common. These are illegal in most countries to be able to do this, but so this company here owns this company here, which owns this company there, which owns that company there. So really, who owns this company? Well, these are really simple to catch with graphs, but even this simple structure has defeated the UK. So these examples here are from the UK. Sometimes they're really pretty simple, but they can't even figure out who owns, 221B Baker Street, from, some Kazakhstan family owns that, but they've got so many layers because they're not always simple. This is a very complex relationship here. There's 139 companies that are in this. Now, if you try to do this in Excel, knock your socks off. So when people say, why graphs? Like, really? Just understanding the complex relationships. But you know what? This would be a good person to talk to. So, so statistically, you can figure that person out by using graph algorithms. Like, so you look at centrality mechanisms. So there's graph principles that allow you to very quickly and easily identify these kinds of things. So these are really good at identifying complex structures. And people think, oh, I've evaded detection. Well, no, you haven't, because we were helping out. So let me talk a little bit about the Panama Papers. First off, who has not heard of the Panama Papers? Okay, I frequently run into this. So we'll tell you a little bit about it, but it's basically, there was a data leak from a Panamanian law firm. What they had was 11.5 million emails, PDF files, passports, that kind of thing. 200,000 shell companies, and they were trying to do this using Excel, seriously. So they're trying to analyze this stuff, and it had information about heads of state, banks, politicians, criminals, royalty, sports figures, a bunch of people like that. So the ICIJ got involved, and then they came to us asking for help. And we were more than happy to provide it, and we helped them win the Pulitzer Prize. This was a real story. This is one of the reasons why I joined NEO. It wasn't just to help Walmart sell potato chips. It was really to do some cool things with current political activities. So the people that were exposed in this, there were, it caught up a lot of high-ranking politicians. More than one of these guys had to resign. A lot of other ones were on the hook. We not only found them, but we're a networking company. We like keeping track of things. So we found their corrupt friends and family. So, it's kind of interesting because we found one guy. His name is Sorkin. So Sorkin is a school administrator who earned $75,000. But he's a friend of one of these guys, and he bought luxury condos in a building in New York and another one in Florida worth $5 million. So you figure out how that works. So being able to spot the relationships is kind of fun. In order to do that, we essentially just created a simple graph data model. And there's a lot of details. If you search for NEO and Panama Papers, we've got like 1 billion blog posts and examples and YouTube videos of how to do this. But this is really pretty simple. I've got intermediaries that are like attorneys, land agents, that type of thing. Entities are the companies. They are registered. We've got officers. So I've got self-joins. An officer of an officer is, who represents who. So I can start navigating this really complex web of people using a really simple data structure and adding a new type of relationship. Say, hey, we found a new way that these guys are linked to these guys here. You just create a new relationship on the fly. There's no schema change. There's no big complex Oracle stuff to have to do. You just start using the new relationship, and you're ready to go. So that was the Panama Papers, and that caught up a lot of people. But the Paradise Papers came along, and so this was essentially even more data. So this one here was 2017. So 1.4 terabytes of data leaked from a Panamanian or Bahamian law firm. Okay, who's heard of WikiLeaks? Everybody's heard of WikiLeaks? Okay, the Panama Papers were 1,500 times as much data as the WikiLeaks. This was even more than that. So we're talking a lot of data, and there's a lot of really nervous people out there as a result of that. And once again, we provided the technical assistance for that. So 380 journalists, and we're still doing stuff to help these journalists. And we have an internship program, and we have a media assistance program. So people will call us all the time and say, hey, can we borrow this guy here? I'm trying to work on something. And we'll get to that in a second. It's useful for finding highly connected people, like our current cabinet secretary, Wilbur Ross. He is still highly connected to a bunch of Chinese companies and companies that are owned by friends of Putin. So he's the person who's making decisions. Now, what you take from that is political, and that's not the point of this talk, but the exposing and making transparent the connections, that's what graphs give you. This is a very simple query. This is an actual cipher query from the Panama Papers to go find the relationships. But this query is what these guys used in writing that article. Let's go find out who this person is and what kind of companies do they own. So this is real stuff using real companies, but it's not just, we caught up the, he's running for governor of Illinois. He says, oh, okay, I don't have any offshore accounts. Turns out he does. His family has tons of them. So what you do with that is, Chicago Tribune, they asked us for some help, and they were able to find it. So we'll get back to Panama Papers and Paradise Papers in a second. But first off, what makes graphs ideal in handling these complex relationships? Fact is, this is a graph. You've all played this game, 6 degrees of separation from Kevin Bacon. I'm sure we all know that. So this person here has 6 degrees of freedom to anything like that. The 6 degrees, we call them hops. But basically, you go to them, you do a join, you do a join, you do a join. So relational databases kind of die because by the time you go 6 degrees out, you could be talking about billions of things. So these graph databases are designed for that. Relational databases aren't. This is also a graph. So this would be 2 degrees of separation from Jared Kushner, as indicated in one of our data sets that's out there. So how do you see the relationships? So that's basically a graph. That's the query. How do I get 2 degrees of freedom from that guy there? Trying to do that in Oracle is a pain in the neck, but that takes like a minute to write. It's embarrassingly simple to do with graphs, to catch the relationships between people. So because of that, you're trying to bring in data from different domains. It's so easy to add a new data source. Like this is a very common pattern that we have. And I can't read this, so I have to put my glasses on. So I've got like unsecured loans. I've got fake people. Who's reusing this credit card? Who's reusing this social security number? This is an actual slide that we use for a financial service company in our neighborhood. So, but what they were struggling with was they were trying to do this with Oracle, and it just wasn't fast enough. But doing semi-structured data and highly connected data, that's what graphs are for. So if that's your only takeaway today, when you're dealing with connected data, think graph, period. The rest of this you'll forget about, but that's the one takeaway you need to remember. So why do relational databases fail? Because relational databases were built in the 70s. You all remember the 70s. We had other great technologies like mainframes and like little bits of memory. So these are all ideas that came and they were good at the time, but they've all been replaced by smarter ideas. You know, like I actually used one of those kinds of things when I telecommuted in the 80s. And my kids like, what is that? Really? They think it's fantastic. But hey, I was able to telecommute in 1983. So it worked. And then other things have changed from the 80s. How many of you still have an 8-track tape player? I mean, the music lives on, but how many of you still have this thing? Technology has really changed over the last 30 years. But why are people still using this database design from the 70s? It really was great at the time, but it was constrained by tape drives and limited amounts of memory. So now that things have moved on, we have better tools at our disposal. Oh yeah, we also have the modern SUV and my favorite, storage mechanisms. So again, things have changed. It's time to move on. So relational databases, the storage efficiency was one of the primary concerns. So you're trying to like constantly do this stuff. Joins were not a big issue because people weren't expecting web scale. So when web scale demands came along, cropped a whole bunch of new web scale type tools like Mongo, a bunch of NoSQL databases, that type of thing. Those were called the NoSQL databases, or the NoSQL databases, but frequently you couldn't do joins. You know, what's the joke? The 3 Oracle DBAs, they walk into the NoSQL bar, but they leave because there's no tables to join. Sorry. Sorry. Some graph humor. So anyway, so like trying to do this, I mean, for years I was an Oracle DBA. I used to write this kind of stuff. This versus this. This is 3 hops. I want to see who works for who works for who works for somebody like that. It's incredibly simple to do. This is actually from Northwind. So we use this example in our training things. So it's really, really simple. What that means is you spend less time writing queries, debugging queries, and it's easier to read. But more important, it's faster. Much, much, much faster. Tons faster. So this is a real graph from findings from a real company. But if you're just doing a few hops, it really doesn't matter. When you start getting into 5, 6, 7, 8, 10, 12, 20, that number of joins, you start getting into really impacted performance. Where Neo, we're designed that way. We're designed for that purpose, so we're really, really fast. So this is one of my favorite quotes from eBay. So they had a MySQL solution that was in there with lots and lots and lots of joins. They were struggling to do that. But thousands of times faster? Yeah, that's not a typo. And 10 to 100 times less code. So eBay uses us a lot. They like us for their recommendation engines, their chatbots. So we are backing a lot of really popular websites. We just never get the credit for it. Okay, so that's a real, and I've got a bunch more examples like that, but we're kind of constrained on time. So NEO, important because when we store data as it's being connected. We call it index-free adjacency. So the data is in there so that when you try to do your queries, you're using memory mapping. So I'm not trying to go tacking around to a bunch of different boxes. I'm just using the data that's in NEO. It's all memory mapped, and so I can do traversals extremely fast. Hopefully that's not me, okay? So anyway, we're really fast. That's the one other takeaway. We like joins, but we're not afraid of them. So what makes this work so well is that a fire alarm? We need to leave? No? Okay, we're good. All right. So, okay, property graph. Okay. We're good. All right, so I kind of frazzled a little bit. All right, so basically, graphs are nodes. Nodes are nouns. Nouns are things. Relationships between nouns are verbs. We call them relationships. So what can you do in the English language armed with nouns, with properties, adverbs, or adjectives? You've got property relationships, which are adverbs. So I can, once I define this person with this name and this loan with this person here, I can find out what bank is making loans on this condo to this person. That's a really simple query. That's 2 lines to write that query. But I also find interesting things like this. This person here is the borrower on this loan, but they're also an officer of this bank. Huh. You might want to investigate that relationship. It might not have been spotted easy, but it's incredibly easy to find in a graph. But you might not have missed it. You might have missed it if it's just in a relational database. So finding these complex relationships is really pretty simple. So all we're doing is we're storing nodes. We have relationships between the nodes, and these things have properties. That's it. It's like Legos. You can build anything with Legos. You can build whatever you want. And to add a new object type is really simple. I want to keep track of persons that bought cars. Teslas are a big deal right now. People are buying Teslas as a way of being able to say, I'll buy it, you drive it. So it's a nice way of giving somebody a $75,000 bribe. Those kinds of things. So they ask us for help. How do we find these things? Well, did you notice that that's the 6th person from that street address that bought a Tesla? Did you notice that kind of thing? That's what graphs do. So that's how you find that kind of stuff, by looking at your data in maybe an outside-the-box kind of thinking. So when you draw these things out, it's not like you throw away everything away you learned when you're dealing with Oracle data. You sketch out your ERD. You plot this thing out. You draw it as on the whiteboard. But here's where the difference stops. We don't go into like second normal form, third normal form, and all of that other crap that you have to, excuse my French, all the stuff you have to do with Oracle. You basically, you draw it as a graph. You store it as a graph. That's how the data is actually stored in NEO. So you store it as a graph. So now when I do queries, I query it as a graph. That's it. That's how I find all of the vehicles that were sold to a customer named Jones. That's one line of code that will traverse that relationship to go find those things. So they like it because like now I can start adding new things about, well, let me know about that kind of vehicle. Let me find out vehicles that have been recalled or servicing or that kind of thing. So graphs are unbelievably simple for adding new kinds of things, which makes it easy for it to work with people like journalists that are too busy focused on the business case rather than the database structure. So you can say, oh, you're looking for this kind of query here. Okay, let's focus on that and let's get you what you need. But again, you design it as you draw it out here, you put your properties. This is actually from a tool. We call it Arrows. It's written by one of our guys in London. And I drew this out using a web thing, and one of the options is you say, show me the NEO. You copy that and you paste it into NEO, and boom, you get this. The insert statements are unbelievably simple. So again, my job is embarrassingly simple. And don't tell my boss. But really, so like trying to do that, trying to set up that relationship in Oracle in less than 5 minutes, really, and having working queries in less than 5 minutes, it's pretty difficult. So we are not really a NoSQL database. And the reason I put this slide up there is because we are connection-oriented. Something like Mongo or Cassandra, these are collection oriented. I'm looking at everything about a particular person. I'm looking for a particular query. So I spent years selling Cassandra, so I can tell you a lot about how this stuff works. And these things here, these are not designed for relationships. They struggle with these things. They struggle with transactions, ACID compliance, a bunch of things like that. I could go on for days. I love this topic, so I have to switch now. Otherwise, I'll be there forever. So this was announced last week, so I got to throw it in here. I've been sitting on this waiting forever for the legal team to approve it. But basically, Adobe, you guys know them, probably. So they've got a software feature called Behance. It's a collaborative environment for creative types. They've got millions of users, and first off, they built it on Mongo. They had 40 terabytes of data in Mongo, which anybody who knows about Mongo, 40 terabytes is a word that just runs screaming. It's an awful design, it's an awful architecture. They have 40 terabytes on Mongo with 125 servers. So they came to us, and I was working at Cassandra at the time. And so they designed this other solution that had 60 terabytes of Cassandra data on 48 servers. If you've priced EC2 instances, anybody do that? 48 boxes. That's more than a few nickels if you're going to be doing that. Just keeping them running, and the DevOps team and all the operations team, keeping them happy and everything. So we came along and said, you know what? We like that you're working hard, but let's try working smart for a little bit. So we put in this project in Neo. They went from 48 boxes to 3. No, it actually ran on 1, but they keep 3 because they want active in case one dies. They can go back to the other 2. So it's available 24/7. And we also shrunk the data down because Cassandra is so inefficient when it's storing data. It's a salesman's dream. I mean, really? You got to buy 48 licenses versus 3? So salespeople like it. But these things are real. I mean, their ingestion process went from 12 minutes to 106 milliseconds. So, but the big thing was the queries were so much more efficient. They were able to do a lot of new things, and so they did lots of new features that are really pretty cool, and also reduce their infrastructure demands. So this was just announced last week, so that's why I have it up there. It's kind of fun. All right, let's get back to the feature presentation. The Russian Twitter trolls. Okay, so this is very topical. There's a lot of stuff going on with that right now. Basically, MSNBC had this information. They were trying to do a story, and again, they were working with Excel. They didn't really kind of know what to do, so they asked for some help from these guys here. These are my heroes of the story, and I'm really proud that they're my colleagues. So I've got Will Lyons and David Allen on there. And they actually didn't spend a whole lot of time, so I can't give them too much credit because this really wasn't that big of a deal to them. But it was important. So anyway, so they did this stuff, and they were like, hey, have you tried this and have you tried this? Because MSNBC was like, okay. They started giving up. And like, no, really, this is pretty simple. I'll show you the code. It's unbelievably simple. So, and it worked. Within a few days of having that data out there, they put that stuff and said, hey, look, here's what's going on. And they issued a real indictment. So this isn't just fantasy. It's not just fake stuff, alt news or whatever you want to call it. This is real. And there's some really interesting things that go on with the data that are in there. So the story behind it. So there's basically, you had a lot of Twitter accounts that were tied to this internet research agency. How they figured out that internet research agency, that part of it, I can't tell you. But I do know that there was a really cool graph database company that helped, but I can't tell you about that part of it. I don't get to post that guy's picture either. But anyway, so basically, but here's the thing: Twitter deleted the accounts. So like, okay, trying to prove this stuff after the fact. So Dave Allen comes up with the idea and said, well, you want to know what tweeting about? Well, there's this really cool thing back out there called the Wayback API. Did you guys know about this? Yeah. It's really pretty cool. It's a snapshot of what was going on at the time. So he said, hey, let's go see if there's anything out there in the Wayback API. Did they capture any of these things? Turns out they did. So we were able to find a bunch of Twitter trolls that were out there, find out their accounts. And we essentially set up a scraping job that would take a tweet like the one on the left, and you could see the information that came in over to the thing on the right. So this is from a Twitter troll called Tennessee GOP. They've got this fake news story. They've got a picture, and they've got a couple of bar attributes on it. So you get this raw information coming back. They ran it through some kind of process that scraped out the relevant Twitter tweet, and it came out like this. Okay, JSON. Oh, okay, we like JSON. JSON's fine. Basically, it was a URL to the picture, who did the tweeting, what was it about, and the attributes. So, okay, that's all well and good. Loading that into Neo was that chunk of code. That really is the lines of code. It's, like I said, it's like embarrassingly simple. So it's basically, I won't read through all of this, but it's basically saying, go get the tweets, process all of the tweets, go find out who the user is, get the tweet information here. If it's brand new, go ahead and do this. And the reason these merge is so you can rerun this script if you have to, and they had to. So create a link between this user posted this tweet. That's an insert statement between a user and a tweet. That's how complex it is. This gave me my user, this gave me my tweet. This is how they found them, based on tweet ID, user ID. And then what it is, we'll get to this part in a second. But then we want to look at the hashtags. And for that, we had to use some natural language processing. So we're doing on time. We're good. All right. So based upon that, they were able to look at 454 of those 2,000 trolls. And they were able to get over 345,000 tweets. And that were eventually retweeted by 41,000 users. A lot of people were like constantly retweeting their things. Some prominent politicians were constantly retweeting the stuff that they were doing out there. So, but this is the lines of code. So basically, this is the data model. Basically, this user here, so this tweet was in reply to this user. This tweet mentions this user. This user posted this tweet. So having two objects with multiple relationships between them, we do that a lot. So if I want to add a new one, go in there, fine, not a problem. I don't have to change the scheme. I don't have to do anything. I just start using a new relationship, and it's done. So this is where the tweet came from, or what source did it. So a lot of these things they were able to discover with some simple things like, well, this guy here, he just joined Twitter like 6 hours ago. He already has 45,000 followers, and he's cranked out like 6,000 tweets. And all of those tweets when he's doing here, that's using, each of them are individual ones. It's like, huh, the DNS server that they're using is this one here in Moscow. And these are all tweets that are during Moscow business hours. Okay, something might be fishy there. So how they were able to figure that out was that kind of stuff. So figuring out how long has somebody been tweeting, who's constantly retweeting, these types of things. So they're able to do that. But that wasn't the end of the story. So like, okay, what's the tweet about? So I've got this tweet over here. This is a real tweet. I actually remember seeing this one. I have family members who send this stuff to me all the time. So goodbye to Barack Obama. Thanks, Obama, for doing this thing. So anyway, so I see some attributes in there. So what I want to do is I want some way of extracting those kind of things from the text. So I use classic natural language processing routines. So this one here, this one's from Stanford. They created this. It's really pretty good. We have a company, one of our partners is called GraphAware. They worked with us to show us how to use it. Again, it's embarrassingly simple. So we did that. Again, using NLP to extract the hashtags from the tweet. And from that, we were able to extend the data model a little bit to add hashtags, which I think are right here. So adding a new relationship to an existing database, like, oh, we got a new data source. We have something else we can do to do that. So being able to modify your data source on the fly or your database structure on the fly is really simple. The code for doing that, again, this is the GraphAware natural language processing engine that we used. Essentially, it's a wrapper that they wrote that goes again around the Stanford stuff. Stanford stuff is open source. It's really good. We have a lot of companies that use it for a variety of things, like sentiment analysis. You've got text. You're trying to figure out lots of different things. Like people will analyze terabytes of data. I need to figure out What's the subject of this? Who are they talking about? Are we involved? Are we in trouble? Those kinds of things. Sentiment analysis. Is this person angry? I guarantee that every tweet that you write that has a hashtag Hertz rent a car or something like that is going to be picked up by somebody from Hertz going, oh, this guy's really ticked. We should probably get a hold of him. That kind of stuff by figuring out sentiment analysis. You can't have people doing that. There's too many of them. So you write NLP jobs like this. But the code for doing that is, again, this is match statement. So this is saying, give me all of my tweets that are in the English language, because this is going to work on English. So I'm going to call some graph-aware NLP method called annotate. So that's going to be in some jar file. So they give us a jar file that this is, so we're going to say take the text is going to come from this tweet. That's this TW. That's a pointer to that. So I'm going to take the text from that tweet, and I want the ID of that tweet so I can go get some other stuff. And that's going to give me all of the tags. All of the tags for that, I will essentially say, hey, go add that tweet has this annotated text of this result. This is how you add the annotated results to it. So that, what is it, 5 lines of code? I can't count. So 5 lines of code to invoke a natural language processing engine from Stanford, being able to extract those hashtags from my tweets and be able to insert them into the proper rows in the database and link them properly. Really, 5 lines of code. So like I said, this didn't take those guys very long, but again, it took me longer to explain it than it did. And really, the code for all of this is out there. This link right here, I think, is this is the NLP library here, and all of these slides I tried to do where I've got the links to the different, what this is using, the GitHub repo with his code. Okay, I see my timer. I'm going to move quickly. All right, so that's what it looks like. I've got this person. That's the query to go find that thing. So that's a really simple query, but I'm looking for the hashtag thanks Obama. So that's how that query is written to go find the things that this guy did. So you had these guys here that pretended to be real citizens, that were pretending to be news sources, that were pretending to be political organizations, and they weren't. So, but you can kind of find out what they did, who retweeted them. It's unbelievably simple. We actually have a free database. We run it in the cloud if you want to go use it and try out the queries for doing this. It's on our website, and I think I have a link to it here. All right, some of the cool things about that, like you could see how it was timed, so you can see when these things were doing. But this is how difficult it was to produce the data for this chart. And that's the query. Go count these things by day. And by hour of day, we started noticing, oh, a lot of these things were coming in from this DNS server, from this particular IP address that pretends to be in a bunch of different states. How does that work? But they're all going through the DNS server in Russia. So a couple of things here. Being able to understand data. So, okay, I'm going to go quickly. So, so these are basic things for like who's important here. Trying to understand who's the most important thing. So you've got PageRank. You've got various graph algorithms that you can easily apply to figure out who are the big players in here. Sometimes you're looking for the person in the middle. Like these guys here. These are the persons that like if you knock out those people there, you kind of disrupt the whole network. So it's identifying bottlenecks. Networking companies use this for like identifying bottlenecks, that kind of stuff. Also, like who's the most, like where is this thing centrally located? You use these kinds of things for where should I position something? Uber drivers, where should I go to get the most rides? So that kind of thing. Then you go to visualize it. And this kind of thing, I love this graph. So this is from a JavaScript library that we provide. But it's basically this Tennessee GOP, the node size is big because they're important based upon who thinks they're important. So again, using PageRank, the color of the graph determines what community they're in, because these people here, they're working with these people, but these people here pick different subjects for their tweets. So that kind of community detection is really useful when you're doing machine learning and you're trying to do feature discovery. Which features should you use in your machine learning models? These really help out that tool. So we work with a lot of people doing machine learning for this thing. And this, the code to draw that graph is like 5 lines of code. And again, that's on our site. We do this in the training that we do, and the next training I think I'm doing in Irvine at the end of next month. So go to our website. They've got all kinds of things on training. All right, a couple of other quick things on here. Other big uses for this. Knowledge graphs. Knowledge graph is what is that thing? I'm trying to look for something. I'm searching for, I'm looking for data. I'm looking for a document. I'm looking for something. But I love this. This guy got up in front of 2,000 people at our user conference and explained, hey, this thing saved us 2 years off the mission to Mars. Really? That's not just money. That's national pride. That's a lot of things. That was really cool. I like that. So I'll put that one out there. And these guys here, they stole that idea. Not stole them, it was available. But they created a knowledge graph using the same kind of context. Every document that comes in, every spreadsheet, every email campaign, every algorithm gets cataloged. It's an artifact. So it's no longer, hey, do you know where something like that is? It's like you just do a query, use NLP to figure out what you're asking about. It'll go through and it'll find the things that you're looking for. So anybody can find data, and it's trustworthiness. Now they started doing cool things, like they gamified it to so if you produce something that's used by a whole bunch of people, you get more points. So they're really trying to reuse stuff. But again, we're not dealing with COBOL and Java and spreadsheets and Excel. We're dealing with modern companies, and we like their example. And I think got a couple more things. So this is our sandbox. So we have sandboxes that are available. These things run on EC2 instances that will fire up. They don't cost you a nickel. So if you want to get started with Neo, you can, there's all kinds of training available. But one of these, I think, is Russian trolls. There's different ones that are in there. The Panama Papers. So we've got preloaded with data, preloaded with queries, and a little bit of explanation about it. So I use these whenever I teach classes because they're nice and clean when I start, and then I can destroy them all I want. But they're really a really useful resource that's out there. And again, these are our experts, the heroes, Will Lyons. And his version of this presentation at Stanford is available somewhere. I've got a link to it. It's in here. But it's also available. And the last thing is we've got our Journalism Accelerator program. So we work with like a lot of people at Berkeley and Stanford are doing this, but basically investigative journalists from all over the world that are using Neo to help do this because graphs are really good. Again, what you do with the information or how you got the data, we really don't care. Technically, how do you associate this? How can you effectively write queries? I get to do that, and I love that part of my job. And that's it. So we got questions. So I'm not going to answer them, but you can ask all you want. So, all right, sure, go ahead.
Yeah, quick question. So, what would a relational database be good for? How the graph database is not good for?
That's a good question. Like financial information, where you are you're really focused on that transaction, the granularity. I don't need a bunch of joins. My 401k's got a ton of Oracle in it. I still use it for a lot of things, but it's solving a different kind of problem where you're dealing with less connected data and the speed of the queries isn't as critical. So I don't know if that helps. Yeah. Thanks. Yeah. Right. Right, so writing timestamp queries adds a dimension to it, a temporal dimension, and it's a data modeling feature but I can show you a couple of links to it. Come by my table, because it's a long answer. Okay, yeah, we've got a table out there.
And it actually built up the graph itself from say Panama Papers data with the NLP, which extracted all the entities.
Right.
And then the relationships between them, that's the sort of
Right, and so we've done a lot of that for you, and then what I'm putting on is a visualization tool that allows you to really, so we've got a demo at our table that kind of does that also. So.
I need to present this.
Oh, cool. Oh, wonderful. Hey, thank you. Cool. Right, yeah, I'm keeping you guys from lunch, so feel free to go. So, cool. All right, thank you. Thank you.
Question about storage. You mentioned
Sure.
in one of the cases in Adobe,
Mm-hmm.
you actually replace their current solution with like much less storage.
Right. Orders of magnitude, yeah.
Yeah, I was wondering because you save everything in picture.
No. We store it. It's just a very efficient storage mechanism. So like in Cassandra, Like if you write, like say you write a query for, I want to find all of my songs by artist, that has a table. And if I say I want to find all songs by title, it actually takes a separate table. So now I've got 2 tables with duplicate information because you can't do joins, and so they're very tuned for that thing. So now if I've got 6 queries, I've got 6 copies of the data. So every time